Hello everyone, this is Poonam. Yesterday we have completed the introduction of the chapter Electricity for class 10th. Today we will continue with the next topic, that is the electric potential. As we know that the word potential means the power, means the capacity of doing work, we can say. So how can we define the electric potential? Suppose we have a small positive charge which is placed in any electric field, and there is one more charge of equal magnitude which is present in that electric field. So both the charges will experience a force on each other. When a small positive charge is placed in an electric field due to another charge, it experiences a force. So some work has to be done against the force of repulsion, because there is a force of repulsion because the charges are similar. Suppose this is the positive charge and one more positive charge. So when they are placed in an electric field, they experience a charge, and a work has to be done against the force of repulsion which is acting between these two charges. Now, what is the definition of electric potential? Electric potential at a point in an electric field is defined as the work done in moving a unit positive charge from infinity to that point. Means suppose we have these two charges and these are placed in the electric field. So the potential means the power, means the work done when this positive charge will move towards this positive charge against this electric field, then this is called the electric potential. And this charge is moving from infinity. Suppose this is the infinity point and this is that point on which we need this charge. So electric potential is defined as the work done in moving a unit positive charge from infinity to that point. This electric potential is denoted by the capital V, and its unit is volt. Now this definition of 1 volt, how can we define this 1 volt? When 1 joule work is done in moving 1 unit positive charge from infinity to that point, means in this definition we have done the work done. How much work we have to done? 1 joule work done. And this is the unit positive charge. How much positive charge? How much unit positive charge means? 1 unit charge, and this 1 unit charge means 1 coulomb of charge. So when 1 joule work is to be done in moving 1 coulomb of charge from infinity to that point, it is called 1 volt. Now there is one more definition, one more point, that is the potential difference. Now this is the potential difference between the potentials. Suppose we have two students and the potential of doing work of the student A is more than B, then this student A can do more work and he can do the work of B as well. क्योंकि वो जल्दी काम करता है तो वो धीरे धीरे बी का भी काम करवा सकता है. सो दिस पोटेंशियल डिफरेंस इज ऑल्सो डिनोटेड एज वोल्टेज. इसको हम वोल्टेज भी बोलते हैं. नाउ दिस इज द पोटेंशियल डिफरेंस, मीन्स द डिफरेंस इन द इलेक्ट्रिक पोटेंशियल्स बिटवीन 2 points, between 2 charges. This the amount of work done in moving a unit charge from one point to another पॉइंट. एक पॉइंट से दूसरे पॉइंट पर ले जाने के लिए जितना वर्क डन करना पड़ेगा, दैट इज द इलेक्ट्रिक पोटेंशियल, और वी कैन से पोटेंशियल डिफरेंस. सो द पोटेंशियल डिफरेंस इज इक्वल टू वर्क डन अपॉन द क्वांटिटी ऑफ चार्ज. कितना चार्ज हमें एक पॉइंट से दूसरे पॉइंट पर लेकर जाना है, दैट इज द पोटेंशियल डिफरेंस. दिस पोटेंशियल डिफरेंस इज डिनोटेड बाय V, work done is denoted by W, and the quantity of charge is denoted by Q. Its SI unit is volt, which is denoted as capital V. So 1 volt is equal to work done which is having the unit of joule. So W is 1 joule and Q is 1 coulomb. So 1 volt is equal to 1 joule per coulomb. Potential difference is measured by the voltmeter. This is the instrument. This is called voltmeter. It is always connected in parallel. And this voltmeter, it must have a high resistance so that it takes a negligible current from the circuit. Means ये circuit से current ना ले पाए जब हम इसको connect करें. That's why it has high resistance. Now this is the question on this topic. How much work is done in moving a charge of 2 coulombs from a point at 118 volts to a point of 128 volts? We have V. This is the difference. Means 128 and 118. So when we subtract these, we get 10 volts. Q, we have 2 coulombs. It is given in the question, 2 coulomb. We have V is equal to W upon Q, and we have to calculate the work done. So W is equal to V into Q. This V is 10 volt and Q is 2 coulomb. So we have 10 into 2 is equal to 20 joule. So we have to do 20 joule of work in moving this 2 coulomb of charge from the potential of 118 to 128. You can solve the numericals by using this formula. Now this is the electric current. Electric current, to flow the electric current, we need mainly the two things. That is the difference in the electric potential and the conductor also. If there is no electric potential difference, then the electric charge cannot flow. So when there is the electric potential difference and there is a conductor, metallic wire or any conductor, then the charge starts flowing from high potential to low potential. I am saying that from high potential to low potential. Suppose this is any of the vessel having a knob in between, and in this arm A and this arm B there is a difference in water levels. In arm A this is the more water and in B less water. So when we open the knob, then as you know that this is a common thing, that this water from A will start moving towards the B because the level of the water in arm B is very less. And this water continues moving, it continues moving from A to B until the levels of both the arms will become equal. If the level of the water in arm A and B will become equal, then there will be no flow of water. That's why we are saying that there should be the difference in the electric potential. Now this flow of electric charges, that flow of electric charges is due to the flow of electrons. The flow of electric charges in a conductor is called electric current. The magnitude of the electric current is the amount of electric charge passing through a given point in 1 second. Suppose we have this point and we need to calculate the magnitude of the current. So how much electric current, or we can say how much electric charge is flowing from this point in 1 second, is the amount of electric current. It is denoted by, this electric current is denoted by I, and its unit is ampere, which is denoted as capital A. So we have the formula of the current, that I is equal to Q upon T, because the amount of electric charge, देखो charge is denoted by Q and we are saying that in 1 second, so this is T. So I is equal to Q upon T. It is also, we can say that the rate of flow of charge is called electric current. So this I is ampere, is in ampere. So we have 1 ampere. 1 ampere is equal to, this charge is in coulomb, so we have 1 coulomb, and time is in second, so we have 1 second. So 1 ampere is equal to 1 coulomb upon 1 second. In the lower, very low units, very small units, we have 1 milliampere, and this 1 milliampere is equal to 10 raised to power minus 3 ampere. Just like the potential difference which was measured by the voltmeter, similarly this electric current is measured by the instrument ammeter. This this ammeter is always connected in series, and we have done that voltmeter is always connected in parallel for the high resistance. So in this, the ammeter should have low resistance so that it may not change the value of the current. Now we have the question: an electric bulb draws a current of 0.25 ampere for 20 minutes. Calculate the amount of electric charge that flows through the current. So in this question we have the current I is equal to 0.25 ampere and we have the time t is equal to 20 minutes. We will convert this minute into seconds. So 20 into 60, which is equal to 1200 seconds. And we need to calculate the charge. So Q, we have the formula I is equal to Q upon T. So this Q is equal to I into T. We have I 0.25 into 1200. So we will solve this value and we will get the answer, that is 300 coulomb. So the answer is 300 coulomb. This is all about the electric potential, potential difference and electric current. In the next video we will continue the next topic of the chapter, that is the electricity.